Hello, my name is Divya and welcome to my presentation on in-process tracking and traceability for zero-defect manufacture of electrical machines. This slide presents an overview of the key points discussed in the presentation. Firstly, results from an industry survey are presented that highlight the importance for inspection of manual processes in EM manufacturing. Then there are two case studies. The first case study discusses simulation techniques that we have used for modeling process characteristics and interdependencies that lead to defects. The second case study is looking at inspection techniques for lid wire terminations. An industry survey was conducted to obtain some insight into the involvement of manual processes and current level of automation within EM manufacturing industry. We obtained responses from 6 UK-based manufacturers, which are shown as A to E in the table, and 1 non-UK based, which is shown as G in the table. The responses from industry indicate that a significant portion of activities are highly manual or semi-automated with supporting manual interventions. The respondents also highlighted that some activities, such as forming reliable contacts, are difficult to automate. When we asked about what percentage of failures could be attributed to manual manufacturing activities, we received an average of 40% as an answer. So this was very interesting that literature focused on automation heavily, whereas industry highlighted the involvement of manual manufacturing activities. And this survey highlighted the requirement for analysis or inspection of manual manufacturing tasks. This work focused on modeling process characteristics and interdependencies that lead to defects. So current literature only presents impact of any one process variable at a time on the onset of defects. And our aim is to understand how defects are influenced by a combination of process variables, multivariate interdependency. Therefore, we used simulation techniques to model manufacturing process of a stator with an aim to determine interdependencies between process parameters. A discrete event simulation model was prepared for linear winding processes for non-circular orthocyclic coils. The winding process was broken into individual steps and then functions were modeled for each step. Literature revealed that disturbances or variations in set wire tension were heavily dependent on the winding speed. And therefore, our model included two main process parameters of winding speed and tension. Our model focused on individual layers during winding and then each turn within that layer. Resistance was calculated at individual turns and then the final accumulated error was calculated. By looking at individual turns, what we tried to achieve was to link process parameters to physical characteristics such as deformation in the wire, to electrical properties such as resistance, and finally to the occurrence of faults in a manufactured component. The simulation model could highlight the local position of faults or high resistance areas as local hotspots. And this information could direct the end-of-line test towards the highlighted areas. The next steps in simulation would be to add more parameters to the model, suggest a hypothesis on interdependence of process variables and fault generations. We aim to do limited physical experiments. And then finally, we'll look at optimization for process parameters to achieve fault reduction. This model is useful for winding processes in industry where a new machinery is being set up and there can be anomalies in the process. This slide presents a second case study that focuses on inspection for lid wire terminations. So the process of creating joints or terminations is highly manual and is difficult to automate. As a result, it has been identified as a big reason for motor failures within the life cycle. Inspection of joint quality can be observed by direct methods or indirect methods. Direct method usually involve visual or thermal inspection, resistance and force measurements, whereas indirect methods involve observing the process or machine parameters. Now, Rolls-Royce has directed us towards a problem with the quality of terminations on lids wire. So the problem is that terminations they look the same, but performance is variable. In order to identify the causes for variation in quality of lids by termination, a failure mode and effect analysis for the process of preparing terminations was conducted. Sensing technologies were identified to capture the process parameters. And now the next step is to capture the process parameters and then link them to the quality of the prepared termination. Thank you for listening to the presentation. If you have any questions, you can contact me on my email address or you could visit our website for more details. Please note that this is part B of the presentation. Part A looks at manual activities during connections and terminations of coils, and it also investigates coil failure classification through machine vision methods. Thank you.